we will going to perform the practical, that is what, to find out the liquid limit test. That is what, whatever the soil sample is given, we are supposed to find out the liquid limit of that soil. Now let us see what is first liquid limit. Now where this term come from? Now there are three types of limits of the Atterberg. Atterberg, who is a scientist, who has given these three limits. First one is the liquid limit, second one is the plastic limit, third one is the shrinkage limit. Out of that, today we are going to learn what is liquid limit. Now let us see the definition of liquid limit. Liquid limit is defined as the water content at which soil changes from plastic state to the liquid state. This is what the definition of liquid limit. Now in today's practical, we are going to perform this test. Now the main aim is to determine the liquid limit of the soil sample using the liquid limit apparatus. Now IS code for this test is IS 2720 part 5 1985. Now this is what the observation table. Before that, we will show you. Now suppose for this test, we have taken this soil sample. Okay, this is what the soil sample. This is what the soil which is passing from that 425 micron. We have collected this soil sample for the our liquid limit test determination experiment. Now out of that 120 gram of soil sample that we have taken, okay, this is what the soil sample on which we are supposed to perform this liquid limit test. After that, now this is what liquid limit apparatus. Okay, this is what liquid limit apparatus is there. We will going to take that soil sample in this disc and we will give the blows. We are supposed to count the number of blows. That is what the function. So whatever the procedure and all these things is there, we will going to explain through the next part. Just now I explained the procedure for the liquid limit test. Now we are going to perform the practical to find out the liquid limit of this soil. Okay, so we have taken this 120 gram of soil sample from 425 micron sieve. Okay, this is what the soil sample of 120 gram. Now we are going to add sufficient amount of water inside this soil to make uniform paste, and whatever the paste that we have created, we have to paste inside this cup. Okay, this is what the liquid limit apparatus we are going to paste up to this height. Okay, we are going to do this procedure. Side by side I will explain the procedure. Make uniform paste so that it should be look like a homogeneous mixture. Now we have make a uniform paste of this soil along with the water. Now we are going to put this paste of a homogeneous mixture in this cup, in this liquid limit apparatus. Let us see this. We have to fill this cup up to the this much height to make the uniform paste in this way, so that all the layers in this downside has to be in equal proportion. Now in this way you have to fill this cup. Okay. Now what we supposed to do? These are the two tools that we have to use. Now first one is the Casagrandes tool and second one is the ASTM tool. Now suppose for this liquid limit test, if the given soil, if it is of the plastic nature, at that time we have to use this Casagrandes tool. If it is a clay soil, then we have to use ASTM tool. So we will going to proceed for that. Now we will going by using, this is what hook, crow or crow, we will going to make an equal halves in this cup, and after that we will explain the procedure. So we will going to make by using this. Now when this part of this screw, when it is used, now it shows the difference of these two layers of the soil. Okay, these were the two layer. Okay, right now after that we have to give the number of blows. Means by giving the blows, what will happen? Whatever the two layers that are shown, they after giving the blows, they are become unite up to the 10 mm. When we supposed to stop giving the blows? When this distance joined by 10 to 12 mm, we have to stop the blows, and at that point we supposed to stop the number of blows count. Okay, at that time we will going to stop. So we will going to start by giving the blows. Let us see here. Now after giving the sufficient blows, what we found? We found that due to giving the blows, the line which join the two parts of the soil becomes joined to each other. Now observe this, the 12 mm of the distance is joined. So at that point we are supposed to stop our blows, and we have to find out, we have to count the number of blows that is given for this test. Now after noting down that blows, we have to take sufficient amount of soil sample from this. In this way we have to take that soil, which is, we have to keep this wet soil in a container, and we have to keep this for 24 hours for in a oven drying process, and we have to find out the weight of that oven dry soil. So right now we will going to do this, and after that what we supposed to find out, in our observation table we supposed to note down the weight of the container, empty weight of container, after that weight of this weight of wet soil along with the weight of container we have to note down, and after 24 hours we will get the weight of the oven dry soil along with the weight of container. So this is what the end part of this experiment. Now after performing the experimental procedure, we have found out this we have founded this observation table readings. Now for the first take, the number of blows they are found to be 17. Now after that, weight of the container that I have taken 20.18. The weight of the container and plus weight soil, whatever the weight soil that we have taken, the weight is found to be 38.24, and after that when this weight container we have kept in oven for after 24 hours, the reading of that container plus oven dry soil found to be 33.52. Now this is what the observation part. Now the calculation part is, weight of the water is nothing but the W1. Now W1 minus W2, W1 minus W2. So we have found that 4.72 is nothing but the weight of that water. And the last one is weight of the oven dry soil. The formula will be W2 minus W0. So we have found that 13.34. This is what the weight of the oven dry soil. Now from that all these readings we can calculate the water content. Water content small w equals to W1 minus W2 divided by W2 minus W0 into 100. So we find out water content for the first trial is 35.38%. Now this is what the first reading. Now if we repeat this procedure for 4 times, we get this total chart for 1, 2, 3, 4. So for each trial, number of blows are 17, 23, 27 and 34, and for that the water content found to be 35.38, 32.82, 30.52, 28.59. So whatever the next part will be there, we will explain you further way. Okay, this is what the observation table format explanation. Now after taking the readings from our observation table, we can plot the on a semi-log graph paper, we can plot a graph of number of blows on x-axis and water content on y-axis. Now this is what we supposed to take for that semi-log graph paper. Now if you plot number of blows for all the 4 readings, we will get this a single line, a single curve. Okay. Now for on this curve we have to take number of blows has to take consideration of 25. If we make an intercept on from this reading from the x-axis, it will going to touch to this curve at this point. If we take this intercept on y-axis, we will take the reading as 31.25%. Now this is what 31.25%, nothing but the liquid limit of a given soil for 25 blows. So we have to take this 31.25%, nothing but the liquid limit of a given soil sample. So this is what the end point of this experiment.